Hello, our next topic is, does our time perception have limitations?
Hi, I am Dr. Mesut Dinsir with my friends.
Frank Genovese.
And John Streeter.
Dr. Drew DeVee.
Karen Miller.
And George Dunkel.
We are here to talk about if our perception of time have limitations. We are a species made to survive. So anything that helps us to get food, for us to survive, we have a pretty good idea what we need to do. But for something, if it's happening in a longer duration, such as if something takes years to show its face, we tend to get lost. We tend to don't appreciate the correlation. Simple example, even in a short time frame, would be when you see lightning in a couple of seconds, maybe 10 seconds, 15 seconds, depending on how far it is, you hear the sound, you wonder if there's a correlation. As a basic surviving species, that may be difficult to grasp, but after a while, you can probably say there is some correlation. But when the time is involved where we see the outcome not right away, later on, I'm a physician, I see some cases such as, say, glomerulonephritis. Few weeks later, a person gets glomerulonephritis after the upper respiratory tract infection. For non-physician person, it's difficult to grasp that. Why, the result of something that happens 3 weeks ago, that you feel it now. There are even some illnesses like HIV, takes 10 years to show its face. There are some even other viral conditions that could take few decades to show their face. So we are not really good in very clearly understanding or maybe perceiving that there may be correlation. If it takes long time, we may be very easily able to understand if something happens, event happens, cause and effect happens right there in front of you. We can say, yeah, there is a correlation, but I think our perception of based upon how much time passes has an impact in our understanding if we can make a correlation or not.
The question posed as such it begs to bring up definitions. Time perception. There are two words there that I think need to be defined, and I think part of the problem is that we have no pure definitions for both. With regards to time, even physicists to this day cannot give you a definition of what time is and what time does. I think most physicists will talk about the arrow of time or the flow of time, and with regards to a directionality, there's nothing in the laws of physics that says that time goes from past to present. It's perceived that way from a human aspect, but from a physical aspect and from a purely physics standpoint, time can go backwards or forwards, and there's nothing in the laws of physics that would contradictory to such. Now, with regards to perception of time, again, I think you have to have a working definition of time, which we don't have. But with regards to perception, is the way we perceive time. It could be looked at in a multitude of ways. There's the circadian rhythm that we have inherently in our nervous system that allows us to inherently feel the passage of time and to predict a certain number of hours passing, which, by the way, is not the 24-hour natural rhythm that we arbitrarily use as time. Circadian rhythm is a little bit different, closer to a lunar system. There is the aspect of a purely physicality time. And of course, there's the Planck's constant, which will tell you that there's no such thing as anything smaller than his time period on a quantum scale. So you're going from the extremely small, indivisible aspect of time to a purely human perception of everyday time experiences to a cosmological time frame reference, which is listed in astronomical units, and so it runs the gamut. Are we limited? Yes, of course we're limited in our perception of time.
So if we look at time as Dr. Genovese put it, as an arrow of time, time's always moving forward in theory. But recently we've discovered gravity waves. And gravity waves, as you know, interact with space-time. Space-time can be warped by these gravity waves, which would cause time to move back and forth momentarily, but this is happening all the time. We are completely unaware of it. To us, time is always marching forward. If you think of us, we're like the fish sitting in the bowl. If you think of me moving the bowl around as time, I can pick the bowl up and move it back and forth. The fish, being in the bowl, is completely unaware that anything outside the bowl has happened. We are the fish in the bowl. We can never experience anything but the time that we experience because we only live within the bowl, and we don't have the capacity yet to see beyond that.
One other point I wanted to bring up with regards to time, the reason why time seems to flow in a certain directionality from past to future is what happened at the beginning of time as we know it now. If you take the Big Bang as the beginning of time, we can't know anything beyond that. We cannot know what occurred beyond the Big Bang. We could speculate. But if you were to use all of your gravitational waves and your quantum effects and all of your cosmological entities, you can only go back to the beginning of time as we know it, which is the Big Bang. Now, there's a second law of thermodynamics which is unalterable. It has something to do with, it has everything to do with entropy. Mm-hmm. And because the past always has a lower entropy, and the future will have, in general, a higher entity. It doesn't have to be that way. That's why we as humans feel the flow of time. So it has everything to do with entropy and what happened at the very beginning of, quote, time.
Well, one of the things always fascinates me is that when you look at the stars in a nice, clear night, when you see those stars, each one of those stars or galaxies represents different time. In other words, we perceive it at the same time, at given time that we have, yet they reach it from a different distance, and each one is not reflection of exactly what they are like now. And each one is different. It's not just one of them. Each one of them is different. So I always wonder if there was a way that you could kind of find at that given time how truly the sky would be like.
You can't do that because the mere fact of us interacting, we're all time machines. There's a certain amount of time for my voice to get to your ear, for your brain to process, for the light to shine from my face to your eyes, and for your brain to process. But by definition, by proxy, it's a natural order of the state of being that we are time machines.
Right.
So everything we do and say is a time machine in the past. Everything. Right. Even our conversation right now, there's a lag time between my voice, your understanding, and your reaction to it. Now, of course, that's magnified many, 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 many times over by looking at photons of light that have occurred at stars millions and millions and billions of years in the past. So everything that we do, that we feel, that we think about, essentially we're in a time machine, and there's a time warp involved. So, again, another argument for the limitation of the perception of time.
So if all the stars that you see at that given instant that you have, things that happened sometime in past for different for each one of them. What I'm referring to is, if there was a way you would know exactly at the given moment you're looking at them how they were right there then, each one being different. Of course it's difficult, but that doesn't mean as a Homo sapien that I cannot think about it. That's what makes us different, because we need to think outside of the box. And that's the main reason why we're having these conversations, because we can always think inside the box, it's easy, but you need to think, what if? What if it was different? So I always think when I'm looking at the stars, not how the stars look like. I always wonder how they truly are at the moment I'm looking at them, but there is no way, obviously, for me to know that.
Well,
I have limitations.
Well, there is a way, and I'm going to place the argument against it now. We know that there are quantum effects. There's something called simultaneity, which Einstein had trouble with. He had trouble with that instantaneous spooky action at a distance. Quantum mechanics will tell you that there is a connection between you and what happens at any given time. So from a theoretical aspect, you can know what, there's a direct relationship between what occurred now and then. So
with everything else.
that's correct.
Yeah, I'm talking about each separate each one of them, whatever stars you're seeing at that location, whatever the time frame, distance is, at the instant I'm looking at them, how they were, like at that instant, if you take enough time going back to any given time. So it's something to think about. Anything else anybody wants to spend a little bit?